Hey everyone, welcome. There is a shared script repository for this course, so if you want access to that in your Earth Engine account, the first link will give you access to the Google group. The second link will give you access, will add the scripts to your Earth Engine repository. These are on the public slides. If you go on the training materials page, search for Herwig, you will find these slides, or the links are written on the dry erase boards as well as right here. Good? Yeah. Think for everyone? All right. With one more person? Okay. I got water. Do you want anything to drink? I have anything. Who here has gotten access to the scripts repository? Who wanted access? Okay, I'll give a few more minutes. Again, if you're looking for these slides on the training materials page, you can search for my last name, Herwig, like his toupee, but not. Okay, again, those links are written on both dry erase boards on either side of the room. So if you still need it and don't have the slides, you can look there to join the groups. So hello and welcome. For everyone here, you are in the import, export, and rendering session. So if you are not intending to be here, you may want to leave now, or you can stay. Can everyone hear me? Fine. Okay. I'm Chris Herwig. I'm on the developer relations team in Google Earth Engine. I'm joined in the back with Michael, who is a SWE on Google Earth Engine. And if you have any questions throughout, raise your hand. Michael or I will come help. More likely Michael, but so I, on the developer relations team, I do a lot to support our users. I also get to use Earth Engine a lot, which is very fun for me. So I have a good amount of experience of bringing data into Earth Engine as well as getting it out or creating new data within Earth Engine. So Earth Engine is cool and gives you access to a scale that previously was completely impossible. So really quickly, I'm going to run through a high-level agenda of what we're going to talk about today. First, some key concepts that are common across nearly all of import, export, and rendering. So we're going to go over those early so we know what we're talking about throughout. Then high-level overview of the types of data in Earth Engine. Then we're going to go to the public data catalog, which in its enormity may not have all the data you need, but it certainly is a catalog that you will want to leverage with whatever data you're bringing into Earth Engine. And we're going to talk about how when you're importing your vector or raster data, how you can make it work well with the public data catalog data. Then we're going to talk about how you can bring your own data into Earth Engine, followed by how you can take the results of your analysis out of Earth Engine, and ultimately how you can create new Earth Engine assets from the results of your analysis. Much of what we're going to go over today are new features that were announced or released within the past month many in the past week. So it's an exciting time to be doing this. As I said earlier, there is a shared scripts repository, which you can have access to by joining this Google group and then going to the link there. So the first concept in our concept section is pyramiding policy, which is unique really to when you're importing a data set into Earth Engine, a raster data set into Earth Engine, and when you're creating an asset from the result of your analysis. And essentially, what we're doing, what this concept means is you have a Landsat image with 30-meter pixels. How is it displayed, or how are the pixels computed when it's zoomed out at like 1,000 or kilometer scale pixels? So you have control over that when you are importing your data in, as well as when you're creating a new asset. The defaults for a continuous valued image, we're using mean. So to compute this pixel right here, we take the mean of these 4 pixels. For discrete valued images, we're taking a sample, which is usually just the top left pixel. So I'm not sure which one is left because it's a diagonal. Yes, beyond that, we have a couple of different methods. We have min, max, mean, sample, mode. Yes. So that is in the user guide as well, in the documentation. It's a nice page. That's where that wonderful graphic is from. The next concept, access control lists, which you may know as ACL, you might know as ACL, you might know it as a different thing. This is how the assets you create in Earth Engine are shared or not shared. By default, if you upload a geotiff to Earth Engine, it's private to you. If you want to give others access to it, you can do that. You need to share it. You can share it with everyone. You can share it with just your collaborators. That's up to you. You can do that on individual assets or collections. If you've uploaded a lot of images, you can do it at the collection level. And excitingly, you can change the ACL using either the code editor or the new command line utility, which we will talk about. Yay. Okay. These should be familiar, or at least some of these should be pretty familiar. So I'm going to breeze through them. Scale is just the scale at which you want the computation done, or if you're doing an export, it's the scale you want within that export, meters per pixel that the image represents. Region is going to be the bounding box or the geography of the area you want to export. Dimensions is an alternative to scale. I think it's mostly relevant for exporting video, where if you wanted to do like a 1080p video, you just specify the dimensions for the output rather than giving it a scale. CRS is going to just coordinate reference system. That's important to know if you are ever trying to export exactly what you're looking at in Earth Engine on the map. There is an implicit reprojection to put it on our web Mercator map. So if you want that image, you're going to want to reproject it before you export it. And CRS transform is a much more complex way of saying CRS and scale. And the second important thing about CRS, so if you don't specify it, we take the CRS of the first band of the image you're trying to export. So if it's a Landsat image you want to export, it's going to be whatever that CRS is for the first band. And CRS transform, scale, and dimensions are mutually exclusive. If you try to use 2 of them or all 3 of them, you're going to get a little error and it won't work. So choose what works best for your application. Okay, max pixel, yes.
Is there a list somewhere where we can get the code, the name of the CRS as used in Google Engine compared to maybe more readable name?
Yeah, so for an individual asset or?
Oh, so if I said, I want it to be a sinusoidal CRS or something, and it's like this website.
Like spatialreference.org, I think is, yeah, or typically if you just Google it, it'll come up. Spatial reference goes to the top pretty fast, yes.
So if you don't specify anything though, and you're using a data product, it's going to take the CRS of the first band can use that for whatever you do, and
Well, for if you're exporting,
just for exporting.
right? There is the same behavior is happening for computations. Yes, Eric would not. In some, what's happening when you're doing the computation but not exporting?
Fly computation, the projection use is generally projection.
Okay.
There are some interesting
It
exceptions,
often
but
goes
for the
to
most part, that's
WGS84 though too, right?
Mercator is the projection you're usually.
Right. Okay.
And
I
there's,
thought the export default was WGS84, but I'm checking that. We just made it.
and there's no default for computations and export. Whatever you're using, whatever data product you're using.
I feel like Michael has something to interject.
The default here is whatever we pull off of the first band, the first image.
So it will be data products.
So if you export, for example, a Landsat scene, you'll get a UTM projection. Something crazy.
But if you take a Landsat image and do some processing on it, and then export it, I think you lose
It's the same.
UTM, right? It defaults to.
Oh my God.
Doing some
I got this
processing
from the
is the
docs.
big part of that. It depends what processing you're doing. There's some processing like reduced regions where you wind up, we lose the projection information. So the classic example is taking two Landsat scenes and compositing them. And even if they're right next to each other, they can be in different UTM zones. But you can imagine there's no meaningful projection information to take from that first band. So we'll just default to WGS84.
And the scale also, like scale, dimension, CRS, those are all gonna be from that. data
Yeah.
product.
So the default, I think this is maybe what you're trying to get at. The default when we have no meaningful projection information is WGS84 1 degree, which is almost never what you want. It might even complain and say like, you probably don't want this.
You can get that on accident quite reasonably when you're doing things like mosaic. So take a Landsat collection, okay, median mosaic, get rid of clouds, you're very happy with your result, you would export it. Why is it WGS84 instead of nice and clear as it started? That's why.
And you just change it.
You can just choose the UTM zone you want from PSG code using spatialreference.org or some other good canonical list.
So moving quickly from and CRS, which is a wonderfully complex topic. Max Pixels is a little bit less complex. It's something to be aware of. It's a nice little warning we have built in to Earth Engine that it's mainly to say we want you to be sure that you know what you're doing when you're trying to export a lot or do a computation that's going to be more than that many, the default max pixels. So it's a parameter you can change. When you see it in the docs, it's something, if you get that error, you can raise it and be aware of it when you're doing exports. If you're doing an export to Drive and you only have like a gigabyte free in your Drive account, that is just something to be aware of, as well as now that you can export to cloud storage. Be conscious of that because there are costs associated with cloud storage, though it's really cheap.
The thing to be careful for here is not, if you see your max pixels in your export is some huge number, 92 quadrillion, don't just copy and paste that number and say, that's my new max pixels. We added this because we want you to think about whether that size of your export makes sense. Sometimes you accidentally put in scale as 1e minus 5, and you're exporting really tiny pixel, sub-millimeter pixels. You almost never want to do that. So this is just a guard to make sure you're doing something sane. So if it says 92 petabytes, don't just like copy and paste that. You're not going to be happy.
Or a bad time.
Okay, so on to exciting things. We now have a command line utility that enables you to do a lot of things that previously you could only really do through the code editor, which is shockingly to me considered a GUI now. Wow. Code editor used to be like where you code. No, it's still where you code. But so with the command line utility, which I encourage you all to install after the class or this course rather than right now, if you want to. It's all you. The instructions are in our docs, and it's actually you get this utility when you install the Python API. And once you authenticate, you can manage your assets right through there. You can create collections, you can upload raster data, which we will talk about. You can control the ACLs of your assets or collections. You can change properties of assets, a whole slew of things that are great and will help you to have assets that work well with what's in the public data catalog. Okay. So quickly, we're going to talk about the types of data in Earth Engine. It's vector or raster. Vector, I'm sure you are all very familiar with these different things. The one thing I want to highlight is the difference between a geometry and a feature are attributes. So, and you can create features with the code editor's geometry creation tool, which I'll show in a minute. But it's by default a geometry. So if you wanted to do like a classification and assign classes, you can do that. You just need to change it to a feature or feature collection. So yeah, I won't dwell on that. And then with images, it's even more simpler. An image is one image, an image collection, it's a collection of multiple images. Images can have an arbitrary number of bands, band types, band scale, and they can have metadata properties. There can also be collection level metadata properties. So for example, the Landsat 8 collection, at the collection level, there's some information about how you do an RGB image. It's like B4, B3, B2, what a reasonable min and max are, things like that. But at the image level, we have many more properties like cloud cover assessment for the entire scene, things like that. And these properties are, I'll emphasize again, are very valuable for being able to work with images in an image collection. So you can filter them, you can find the image you want from that collection without having to rely solely on the asset ID. Okay, quickly we're going to jump to the public data catalog. Woo, big numbers, more than 5 petabytes. There's a lot of data in there. I understand it might not be all, it might not have everything you need, but there's a lot in there, so take advantage of what's in there as well. Very quickly, the Landsat archive is massive and gives you a 40+ year record of the changing Earth. Landsat is now joined with Sentinel-1 and 2, and Sentinel-2 is pretty nicely compatible with Landsat bands. So right now, excitingly, Landsat 8 is capturing between 500 and 700 scenes a day. Landsat 7 is capturing around just a little bit under that. Together, about 1,000 scenes a day. And they both have about a 2-week to 16-day revisit rate, but they're staggered by a week. So you more or less get an image every week. And I'll talk about Sentinel-2 in a let me just jump there right now. Sentinel-2, we will praise Sentinel-2. 10 meters per pixel, great imagery. When the second satellite launches next year, ESA is targeting a revisit rate of 5 days. So you throw that in the mix with Landsat 7 and Landsat 8, and you have a pretty cool cadence for imagery that is really nicely compatible in terms of bands. Sentinel-2 also is going to go, it captures images above where Landsat currently does. So Landsat only goes to 82.6. Sentinel-2 will go up to 84, which is great for the top of Canada and Greenland. Yes, let me jump back here. We have more than just Landsat though. MODIS, terrain data, land cover, atmosphere, many more than 200 public data sets. At least 4,000 new images every day get added. And we can estimate that 1,000 of them are Landsat, possibly. Cool. Yes.
So the 5-day revisit at the equator, is that with just Sentinel-2 or is that after they launch the second satellite?
That's when this constellation is complete with the 2 satellites.
Okay.
Right now, I would assume I haven't heard of a revisit rate right now with just the one.
Any idea?
10 days? So that's even incredible.
And we're pretty current on all of them.
Right, and so the Sentinel-2 images about a day delay from when it's acquired to when it's in Earth Engine and accessible. We try to keep it trying to make it sooner, but right now we're about a day.
A lot of this is done too. I mean,
We love that.
they do a lot of work.
Okay, so now we've briefly touched on the public data catalog. Let's talk about how you can bring your data into Earth Engine, managing your assets. Okay, so within the code editor, we have an assets pane, which we're going to refer to as the asset manager right now. And it's just, I'm gonna jump there right now. It's just this tab is the asset manager for you. So jump back here. Okay, so within this interface, you can upload raster, GeoTIFF raster data. You can manage your uploaded sources, delete them. You can edit metadata associated with your assets. You can create image collections and folders. And you can also change the settings for how or if your uploaded data is shared. You can also view your quota, which I'm sure a hand's going to go up. What is our quota? How much quota do we have? Which we'll go to shortly. Okay, so and this is just a quick animation showing editing properties of an image in that code editor. It's very simple, or in the asset manager. It's really simple. You can create string properties or numeric properties, and then as well as this date field, which is valuable for filtering by date if you have an image collection of date-specific images. If you're doing something like an image collection of annual images, maybe that date isn't really relevant and you just want a year attribute that corresponds to the year. It's up to you. It is easier though to have it that way than to have it in the asset ID itself. So just add it right there or with the command line utility.
When you add the date, you just tell it like what is the date, or
Yes, let me just show you right now. So we're gonna add a date to this. So you see it's just like year. Leave it like that.
oh, okay.
You can also,
Becomes the system start time property.
yes.
So, but if you were gonna bring in like, say, a bunch of I don't know, images that all had like a month year assigned to them, you have like. So then you have
So I have a solution for that. Give me a slide. I know how that would be scary, but it's not so scary anymore with the command line utility. You can assign that when you upload the raster with the command line utility, or even through the code editor, you can assign it on each upload. But this is, I think the command line would be a more streamlined approach if you're doing a lot of those. So this, it's just a flag you use on upload. Here we're setting it on an existing asset, but you can also do it when you upload the asset. With the command line utility, you can also set properties. As you see here, you can define it as a string, a number. There you go. But these two, you can set properties and the date of the asset at the time of upload. So it's, yes, so quota. So if everyone with a laptop, you want to go check your quota right now, it'll be interesting to see what happens. I suspect I know what will happen, but you go to the assets tab, and when you hover over your user / whatever your directory name is, you'll see this blue disk usage icon here. When you click on that, this will pop up, which probably isn't blued out like mine is, but I was ashamed of my usage. And so it'll show you the total number of files, total number of assets, and how those relate to the maximum quota you currently have. By default, all users have 250 gigabytes of quota, a storage quota associated with their account. That's different from drive quota. It's different from cloud storage quota. This is just dedicated for your Earth Engine assets. That is a lot. It seems like it's a lot. It might seem like it's not enough. If it's not enough, reach out. It's something we can change, but yeah. So has anybody tried to check their quota yet? Yes. What do you have?
less than 1%.
Oh, so okay, but you don't have 0.
I don't have 0. But
Okay.
I don't think I have any assets. So.
Okay.
Why would I have anything?
My maximum is none.
Maximum is none? Okay, I've heard that. That was yesterday. That's a bug that's been reported. It doesn't mean you have infinity, I think.
No.
Quick, upload everything right now. No.
I do. I just remember. Fusion.
Okay. So, Michael, what time is the session ending? 1? I would assume 1. Okay, in the code editor, you can also create and manage image collections or folders. I would encourage you to do this early rather than late, so you don't end up with an assets directory like me, which is it's a long 200-line list of assets and then folders that I created after. So yeah, so you can start early, create folders for different projects you're working on and organize your assets that way. And then you can either move an asset into an image collection or you can copy it in there. So if it doesn't make sense to have it permanently in that collection, you can just copy that in there and it'll stay also in the folder list. So let me just.
In the command line, can you just print out your directory?
Yes, that's. So we're gonna just. Hopefully everyone's familiar with this page. This is our user guide, and it's a nice section on the command line tool, and you see there all the different commands you can go with. ls is probably what you're thinking of. I forgot to mention the tasks aspect. Cool. You can check the status of a task, cancel it if you don't have a batch task. Okay. So, and again, of course, you can create these image collections using command line utility if you like. If you're trying to move a lot of assets into a collection, it might make more sense to do it with the command line utility. The command line utility code snippets in this presentation, if you attempt to run them, will not work. I don't believe you have access to my users, but maybe.
I can fix that.
Yeah, if you do, let me know.
You have a lot of quota too, so their uploads will probably work.
Probably. That would be. Okay. Who here has uploaded vector data to use an Earth engine before? Okay. How have you done it? Fusion. Shape escape, fusion tables, okay.
I did the other way. It didn't make sense.
What's the other way?
Well, just like the columns that were in like
Yeah.
didn't retain any of that information.
I've had that problem with OGR. It's OGR.
Currently, is that the only way to take this? Because it's sort of.
Shape escape is a third-party programs platform, so we can't really.
For smaller files, Shape Escape is nice because it deals with some of the inconveniences for you. But if you're careful and you know what you're doing, OGR to KML is often the most robust approach, especially if the file is large.
Is KML by default a Fusion table?
Yeah, when you go to upload a table to Fusion Tables, you can pick KML file. And that will work as long as the KML file is created properly. The issues aren't doing that. Shape Escape makes some judgment calls that are right some of the time, but it will sometimes do the wrong thing. So if you have OGR, it can sometimes pay off to learn to use it more carefully.
Yes, so with Fusion Table, it's our current way for if you have a large vector data set you want to use an Earth engine, you would upload it to Fusion Tables and import it as a feature collection. Couple of things to know, you can use either KML or CSV when you upload to Fusion Tables. I believe CSV upload is limited to point-based geometries.
Or addresses, I think, geocodes things.
Right, or something you want to geocode within Fusion Tables. There's also a 350,000 row limit that's on Fusion Tables side. If this is a blocker and it's hurting you or what it's not letting you do what you need to do in Earth Engine, that's another time where you should reach out. There are things we can do on our side to help. But Fusion Tables is not the only solution. Perhaps you don't yet have the vector data set you want to use in Earth Engine. You can create that yourself in the code editor very easily using our geometry creation tools. Again, I'm going to emphasize you can create features and feature collections in the code editor, and I'm going to demo that right now because it's not always known. Okay, so here, just in the code editor, looking at some pretty picture over San Juan, Puerto Rico, and I'm going to create a polygon with no significance right here. And by default, it's created a geometry here. Let me go slower. Click the crank there. And you can choose how you want to import it as. So I'm going to say feature, and I'm going to add a property class. If you wanted to do like a classification where you have different features have different values for that property, what you can do is create each class as its own feature collection and then merge the feature collections after. Because right now, when I go to feature collection and I'm assigning this property, that's assigned to all of the features I'm creating in this as part of this one geometry. Does that make sense? So if I wanted multiple class values, I would just go and create another layer like this and say this is also a feature collection, but the class is 1. Make sense? Okay. Yes.
You can't upload feature collections.
Can
you upload your own feature collections, or can you only create them?
Absolutely.
Through the command line?
No, sadly. Unless it's a small feature collection, like you can also just directly copy and paste GeoJSON into the code editor. If you have a reasonable amount of features in that, you can do that. It's up to you. You'll know if it's not a reasonable amount just by that. But if you want to take that approach, something to know is you just give the features of that JSON object to the feature collection constructor, and that will give you an Earth Engine feature collection.
This approach is kind of a last resort. Sometimes it's very convenient to have like a canonical boundary and create a new shapefile with one row in it.
But for like a feature collection with attributes, you would recommend?
Lets you share it. It lets it be bigger without bogging the script down.
Okay. So now to another fun section. Let's talk about how you can upload your raster data and use it in Earth Engine. So we'll start with the code editor, where you can use the interface to upload GeoTIFFs and add them to your account. So right now we support GeoTIFF for upload. If I was asked actually to ask what other formats would be of interest by a show, like, so if at the end of class people want to just scream formats, or even right now, and I'll write them down. What formats? Raster map files. Oh, PC raster, okay. I'm going to assume though it's what open spec file formats of interest. Is that an open spec? Okay, I'll write it down.
NV header files, which I think is
Okay, NV header.
although it's not that hard, you can do
Okay.
Maybe HCF.
HCF, yeah. NetCDF is what I've heard a lot. Okay. We may send out actually a survey after just asking, like, of these 10, which would you choose first to get a sense of what to prioritize. Right now, though, we do GeoTIFFs, and there's a per file maximum of 10 gigabytes. That means if you have a 30 gigabyte GeoTIFF, which is possible, you need to cut it up before you attempt to upload it. Yes.
Do you support compression in GeoTIFFs, like the internal compression?
Yes. So when you upload, you can assign properties to that asset. You can choose the pyramiding policy, which again is how we're going to determine what the non-native scale tiles look like or actually contain. And we support tiled uploads through this interface by just simply multi-selecting. So if you have like 5 geotiffs you want to upload into a single asset, you can do it this way. You can do it this way. I probably would recommend you do it in a different way, which I will show you in a minute using the command line utility.
How about uploading GeoJSON?
So we don't support uploading vector data into an asset right now.
We direct people with that need to.
Is the projection of the uploaded asset?
It does not, provided it contains proper projection information. Something to be aware of, though, is if it's an extremely north polar projection and it's outside of the valid or the region of a Web Mercator map, you might not see it on the map when you try to add it to the map because ours goes to 85.
But you can interpret any projections that are out there for those pieces.
I will caveat that with Earth projections.
We can do manipulations and other projections if you can define them up in KC. But our catalog of recognizable codes is not populated, of course, the IP catalog, for example. So if you work with other astrological bodies, it's not going to help you.
No, I work with standard. The one ones that are in the
Question in the back?
So limit just on the upload, so you could upload and then mosaic your 3 split up image and then share that asset, not in the storage.
Right.
Images of 10 gig, is that right?
Yes, but if you're going to go that route, I would recommend the command line utility, which will also take multiple tiles or multiple input geotiffs and create a single asset for you. And doing a 30 gigabyte upload through the browser doesn't sound fun to me.
No.
Okay.
What are the supported methods for pyramid other than mean and the upload?
They are.
Is it like the typical functions, max?
Yes.
I don't need the complete list. I just want to make sure.
Okay. It's right here too.
Control cannot run a custom user-defined function for Pixel.
You don't have some.
Don't have some. It's the first time I've ever heard that
Population.
request. Okay. Okay. Well, I wrote that one down. That's the first time I've heard that. Okay.
I can give you more details. I mean,
For population, it makes sense.
No,
Yeah.
it's a very obvious function.
there's a workaround with density here.
Don't do it.
Yeah.
We'll just fix it.
Okay. So then, yes, so you can also do this with the command line utility. There still is that 10 gig per file maximum per file. So if you have the 30 gig geotiff, cut it up into smaller ones. And then you're going to stage the geotiffs on Google Cloud Storage, and then we will ingest it from there. So that's the one other caveat. Command line utility upload, you need to have the geotiffs on cloud storage. So
Fine.
you can set the metadata properties when you upload. Yes, all of this is in the docs for command line usage. And now we'll go to the fun part. So tiled raster upload. This is, a lot of people were excited about this in other sessions. So I have 5. I took 4 tiles of this 10 centimeter high resolution ortho imagery over Puerto Rico data set from USGS and uploaded them into a single asset. I assigned the date and gave it a property, and this is the output asset ID. 10 centimeter ortho imagery in a very cool way actually goes, it was the first time I ever ran into I realized that our max zoom of the map in the code editor wasn't enough for me to see all of the details of this data set. So you can try it out right here. This is if you have access to the shared script repository, it's script 00 under upload. and or you could just go to this link right here. I'm going to show it on the big screen.
So in this case, example, there are 4 JSON files, and each of those has to be 10 gig or less.
Correct.
The other thing that's missing in that little example is that that's the fun part at the end, but there are 4 simple commands you might run before to push each of the files in Google Cloud Storage if they weren't already there. They have a command line tool as well, which is kind of simple one-liners with similar sounding flags. And you do an authentication dance at the beginning, the same way you do here, and then you're good to go. So it's usually a 2-step punch. Push your file, and then tell us to test it.
So it's a small, it's a very small amount of imagery, but these are the 4 tiles. And this is the max zoom of our base map. I could go further. Like, I want to trace these trees. Yeah, so this was the first asset I created with a command line utility. Any other questions?
So is the code editor limited to the max, or that interface limited to the maximum of the base map? Can you keep going in if your data in more detail?
I think there is a hard-coded max zoom in just what, when you like create a Google Map layer, you set the max zoom.
1100.
I'm going to write that. I'll also write that down as a feedback because
It's not very often.
this was the first time I hit it. Yeah.
Very few people who have subsetting together.
Okay.
Right now, with my camera in this chair.
Okay. So now we're going to move away from bringing data in and talk about how you can take your results out of Earth Engine. First of that is we're going to talk about exporting images. You can export an image to Drive, to cloud storage, or as an Earth Engine asset. And here we're going to, this example is example 1 in the export of the script repository. And this example is meant to offer one approach for, I want a Sentinel-2 image, I want a Landsat 8 image, like the source data. That's not really what Earth Engine was designed for. It was designed to make it really easy for you to run your computations on that source data and export the result. So if this is what you're after, there are some caveats to know going in so that it's to make it a little easier for you to do that. The first, you can only specify one scale value. So with Sentinel-2 imagery, for example, that some bands have different scale or different resolution. So you need to pick one or export multiple images and combine them after. The same thing with pixel type for the bands. Your bands of the export all need to be of the same type. So you can either break it up into common pixel type bands or cast them to a good fit before, which it just doesn't feel like a good idea, but if you want it all in one image, you can do that. So here, this is just exporting a Sentinel-2 image, grabbing the scale from the RGB bands, grabbing the geometry of the image, or the footprint of the image, and using that as the region for our export command. And yes, so when you run this, who here's ever run a batch task in Earth Engine? Okay, so let me show you what that really means, because it's a little bit different. Okay, so here's that same script. You add this to the map too.
Looks like you already had that line above.
Oh, you're right, I do. I just wasn't zoomed over Denmark. Okay, so if you saw how the tasks tab became orange when I clicked run, that's because this is why I don't want to show these tasks. I have all these failed tasks. So when you click run here, that's when you actually start the export task. And maybe I can do this. There we go. little bit better. Here you can, if you want to override the scale you provided in the actual code, you can change it there. You could also say like, no, actually I want it to go to cloud. If you want to store the output in a folder in Drive, you can do it there. Specify the file name. One thing, also the task name for all these can't have spaces. So a description to me instinctively seems like it could have spaces, but it's a task name really, and that task name ends up here. So I just saved you from getting an error message which says task name cannot contain spaces. Okay, so yes, so if you want to run this, you would go click run over there, run, and then you see that this is now spinning, and we know it's running. And then when you click on the question mark, you get a little bit of information about what the status of that task is. How do you know if it, ooh, that just totally failed. Oh God. Yeah, max pixels, cool. Okay. So that's how you know if it failed too. It'll turn red, you go there and it'll probably not print out a stack trace, but yeah, so I'm not going to do what Michael said. I'm going to not do what Michael said not to do. Okay, so, but the other thing to keep in mind is if you ran that export, it's not going to look like what you saw in the code editor for an important reason. So what do I mean it's not going to look like what you saw in the code editor? In the code editor, when I added it to the map, I gave the add layer some visualization parameters to make it an RGB image with a reasonable min and a max so that I could see what was going on in the image. But when I exported it, none of that was applied to the image. So I was just trying to export the source data. So if you want to export what you're seeing in the map, you actually need to throw in an additional step. This is script 2 in that scripts repository. And that step is right here. You use the visualize to apply the visualization parameters to the image. And doing this changes what Denmark is. It becomes a free band RGB image, or RGB 8-bit image. Then when I export it, the output is what you see in the code editor. The other thing I'm doing here is I'm adding a fourth band as an alpha channel so that it plays nicely with QGIS. Say helper, and I'll quickly show you. Exporting this as it was, got some no data, not really marked right. So the fourth band alpha channel is pretty supported elsewhere. So if you want to add that, you can do that easily by just taking the mask and converting it to a 0 or 255 binary band, and you have the valid data mask for your image. So this is without it. This is where I was like, well, maybe I'll just tell QGIS that 0 is the no data value, and that made me very sad. This is after we just add the mask as a band. QGIS knows what it's doing. So save you some headaches. If you want, add an alpha band. Okay. Yes.
Is there any option to increase the bit depth of that visualized export to do like a 16-bit RGB?
Yes, but you wouldn't want to use so image.visualize is going to create an 8-bit image. So if you wanted to have a 16-bit image, you would
do the math yourself,
yeah, you would
but
do
it's
the math.
just linear and stretch, so you can totally do it. The bigger question is whether or not all the tools involved support 16-bit. I would want to try it to be confident about saying either way.
Yes.
When you do the export, you show the size per pixel. So that's like default to what the image is.
But-
10, set to 10.
So you supply that when you do the export command. There's a scale parameter you can give it, and throughout this I've been using the scale of the image's RGB image, or the RGB bands, because that was what was relevant to me. If you wanted to do a coarser resolution export, you can absolutely do that. You just change it.
Yeah, and so that was the question. Is it just resample it to coarser resolution, or how does it actually do that?
It's going to choose tiles at the level closest to the desired scale you want, or in Earth Engine, it's going to run the computation using that pyramid. Remember we pyramided it?
Right, and it's going to be mean by default unless you change it.
If it's a continuous valued image, yes.
Yeah.
Yes.
Is there a way within Code Editor to start a bash job without the extra step about going to task?
Not to my knowledge, but I will write that down as another feature request.
That's important to do because you're doing it a lot.
Frequently, yeah. One of those tasks.
Are you doing edits in between each run?
Yeah.
You probably just want a really do it please. Right? Like shift click, don't ask me, defaults are good, I know what I'm doing.
I was under the impression that if you do an export job without visualizing, that was a form of batch processing. You could actually hit run and it's doing your export in the background.
So the exports, when you're exporting data this way, they're all going to run as batch tasks. Here, when I'm adding it to the map, that's a different type of computation. That's like the on-demand computation where we're getting map tiles really quickly. The map add layer of the visualized image is just a different task from the export of that visualized image. One's running at in batch, which might take a little bit longer, but gives you more time per task. So you can, whereas the map tiles, we're going to get them as soon as we can to you.
And once that export job is started, I hit that run button and then I'm not doing any map visualization. Can I close the browser? And
You can turn off your computer, right? It's running in the background, doesn't matter. And if it's going to drive, right, you don't even need to really open the code editor. Eventually it will materialize in your drive folder if you have it syncing to your computer. Yes. Just be aware if you have it syncing to devices with, if you have it syncing to devices with limited storage and you're exporting a lot of geotiffs, be aware. It's going, like,
I will start winding.
So when you export and export it as an asset, you had a workflow, let's say that the ones that seem like a percent forest cover per cell, and you wanted to add that to do another analysis. You could have like 2 different codes. That would be the best way to do it. So you just pull it up as one of your own assets in workflow.
you could do it that way, depending on how computationally expensive it is. That might not be the best workflow, but yes, you can do it that way. It's a sort of like asset as an intermediate. It's like an intermediate asset.
Yeah, like holding it.
Yes.
The best way to do everything is on the fly because it's faster that way. If you have a really expensive computation, you hit a memory error or a timeout. Exactly do what you just described, the export an asset as an intermediate state and continue processing it.
Sometimes you need the intermediate state. Sometimes it's a result.
Yeah.
Like something you want to publish, share, or just be able to find again without worrying about it.
So, and I often need that intermediate step, but
Okay. I mean, but you could also do it to Google Drive and then have it import from Google Drive.
that's going to add a step of creating the asset again from a geotiff, which probably wouldn't save you any time.
Right, exactly. Okay.
And it's different quota.
Oh, okay. Yeah.
The drive quotas again.
So you can use that as a workaround if you're running out of either one.
If you're running out of our quota, reach out.
Yeah. Let's strike that from the board.
So, yes, so
Yes, you have 2 quotas. You can sort it.
30 minutes. Oh, thank you. We are now going to go talk quickly about exporting images to cloud storage. Some things to know if you want to export to cloud for any of these things, you need to have set up a project with billing enabled. It's the key thing so that you can have a bucket in that project. In our docs, we link to this cloud storage quick start page. I recommend you check it out for getting started. I'm also going to talk a little bit about our cloud, our Geo for Good cloud grants at the end, which provide credits for cloud usage for users for doing great work for their projects. So the billing aspect of this doesn't have to be the end for you. We have programs to support our users who need the cloud capabilities. But yes, so you need a project with billing enabled, create the bucket, or you need to have write permission to the bucket you're trying to write the file to. So either you're an owner of the bucket or the owner has given you write access to that bucket. When you export an image or a video to cloud storage, the file is going to have the bucket's default object ACL. So if by default new objects added to that bucket the policy says they should be public, the video file will be public. If by default new objects in the bucket are private, they're private. Yes, and so if you look here, the command is very similar to all the other exports. The main difference is this bucket and file name prefix, which in object storage, there aren't really folders or directories, but you can organize stuff in there like that if you want by using, there aren't like technically folders, but you can use the / to create directories within there. So here, I'm just saying, like, let's make an example export to organize all of our example exports in that bucket. Okay. So now we're getting to the newest of the new, exporting images to Earth Engine assets. Who here has ever wanted to do this? Okay, there we go. That's good. So now you can. And this script, I believe it is not anywhere near here. I think 3. Script 3. Yes, script 3 in that export file. If you attempt to run it, you're not going to be allowed to write to this asset because it's mine and it already exists. So you want to change that. But some things to know with this: monitor your storage quota using the asset manager. So be aware if you're nearing that, which as of now, I would be shocked if anybody really was, because we just recently created the quota system and gave the ability to upload data. So the new parameter here is this asset ID, which is what the asset's identifier is in Earth Engine. So it's, for the most part, the last part of this string, but here I've created a folder in my assets that is just for the user summit, and I want this to be the asset name of it. Again, here I'm just grabbing the image extents for the actual geometry of the image itself as the region I want to export. I did that for convenience. If you're only interested in a small area of it, you can always choose your own region and you just specify the region with region. As well as scale, native image resolution might not be the best choice for a lot of applications, so that's something you have total control over. And here, pyramiding policy. So this is funny because using the sample pyramiding policy on an RGB image makes no sense. But here, I want to highlight that if you want to, you can have different bands in the image have a different pyramiding policy. If you want them all to have the same, you just use this default shortcut. If you want them to have different policies, you provided a dictionary with band name and then the policy. So you could do like red, mean, green, sample, blue, mode, which would make an odd image, but you have that capability. The main use case I think of for that is I have an RGB image as well as a classified image. I want them in the same asset. RGB should be mean, classification is going to be sample. Right. And any questions so far? No? Yes.
What about using this from Python? What's the same?
I assume, but I cannot confirm. Python, I have not checked the Python API. If it's not yet available, it should be soon. I believe it is though. Eric, do you know offhand whether the Python API supports export to asset?
I thought it did, although you do have to update your Python API.
Okay, yeah.
If you've done so and it's not there, then you may have skipped a step. Let me check.
Okay. 34, good. Okay, and so now if we want to check out this exported asset, this is script 035. So beautifully named, and I think it's actually going to not show anything different than what we're looking at right here. Oh, this is a Landsat export, okay. Still over Denmark. This is using Landsat surface reflectance. And we see that there's truly has been a new asset has been made. And you all should have access to this asset, and I encourage you to use it and use it for whatever you want because it's a single Landsat 8 image. I love simplicity. Yes.
The only difference between export to asset and export to cloud storage is that one of them is limited.
There are many differences between exporting to asset and exporting to cloud storage.
Okay.
Export to drive and export to cloud storage are almost identical
Okay.
because in both you're exporting a geotiff
Mhm.
and it's not an Earth engine. It's not something in Earth engine anymore. You've taken the results completely out. When you're exporting to an asset, you are just creating a new Earth engine image. So it's not a geotiff. You can't open it with QGIS.
You can only open it
Right.
with. Okay.
You can always export it if you want, but if you want to still be able to use it, if you want to still use it in Earth engine, you would want to go with the to asset.
Mhm.
Beyond, no, I'll skip that. Cool. Okay, you can also export video, which is not really a new feature, but it continues to be a cool feature that I use for random things often. Who here has ever exported a video? Okay, you've tried. Okay. Okay, so with video, you can go to Drive or cloud storage again. And some things to be aware of going in when you're attempting or when you want to export videos. It needs the video is created from an image collection. The order of the images in that collection matter. So you want to order it appropriately so that the frames in that video go with what you want. You specify the frame rate, the scale, or the dimensions for that export. The images in the image collection need to be 8-bit RGB images. Yes. Why? I believe that is the encoder. It's the.
That ever being changed? Why would you? I had a analysis of flood extent.
People who want like 16, 9.
Something that's not RGB.
Okay, yeah, that's not unreasonable at all. The format is MP4. Like other batch tasks, exporting video can take time. Exporting video can take more time though. So like go into it knowing it may take longer than exporting an image because really you're exporting to get to that video export, you're exporting however many frames you have. You need to create each frame before we're creating that video. So it might take a little bit longer than expected. And the task isn't broken until it's red. So you can check, but don't fear if it's taking a while, fear when it's red. Unless it's like really, really long. But yeah, so here I'm in this, this is script 4 in the export. And what I was doing was I wanted a video, actually I was doing this. I wanted to make a video where showing every Sentinel-2 image over Sydney, Australia. And you'll note that a lot of it is cloud, but some of it isn't, and some of it's just pretty. So you can see how some of the Sentinel-2 images, the registration is a little odd, but this is pretty easy. And what I did after I exported it was I converted it into a GIF so I could play it in the presentation just using FFmpeg. If you want to do that with your exported videos, you can use that. Yes.
On that export, if you did have monochrome imagery, could you specify the same band 3 times?
That's what I was thinking. Did you try that? Person who wanted grayscale? Okay. That doesn't seem like the right solution, but it does seem like it would work.
I think called .visualize. There's an option of .visualize that you can do exactly what this is. But you're right.
Okay. And so here, in lieu of scale, I'm specifying dimensions. I just wanted 1080 by whatever width made sense for this region. And dimensions, you can either give it, this is width by length, I believe. So you can either give it a number or a string where it's 1080 by 768, and we'll interpret it correctly. I also specify frames per second. This, I wanted it to be rather slow because there weren't that many scenes. But if you have like 1,000 images you want to compress, maybe 1 frame per second doesn't make sense. Okay, so we'll take a look at that again. Time's still okay. You can also export video to cloud storage. Again, you need to have the project, billing enabled, and write access to the bucket. The video is going to inherit the default object ACL. Okay. You can also export vector data from Earth Engine to Drive, to cloud storage, or just to the console, depending on what you're trying to export. So here is a really simple feature collection, and there are only 4 features in it. And if you wanted to export that to Drive, you could do it. You have a couple of different formats to choose from: KML, CSV, GeoJSON, or KMZ. You could also do this to cloud storage, which is a slightly different language there. With this, though, to me, it really makes more sense to just print it to the console, which is going to print it to as GeoJSON anyway. So you can print it there and copy it. Lastly, if you're working with a small feature collection and you just want to use that outside of Earth Engine, you can also just do feature collection.getDownload URL and specify the format in there. I believe it's lowercase for that one. So, but you can get KML or JSON or CSV that way. Is that real good? This is script 6. Yes. Okay. Now for the really fun part. Let's talk about exporting maps. Who here has wanted to export a map from Earth Engine in the past? I have all the time. So you now can export static map tiles of the result of your analysis. Woo! These you export to cloud storage. So really quickly, when you use export map to cloud storage, you're going to export map tiles, where a map tile is a 256 by 256 image tile. So this is what the world, this is zoom, I don't know, 2, 3. This is the world broken up into 256 tiles. Similar to, but different to export video. When you export map tiles, you need 1 or 3 band images. And the output map is publicly viewable. In certain instances, it will not be. I'll explain that. It can be embedded on other web pages. It doesn't require the viewer to be a registered Earth Engine user. If you're exporting, you need to either be a writer, or you need to have either writer or owner access of the bucket you're attempting to write to. When is the output map not publicly accessible? If you use write public tiles equals false, which means that rather than writing public image tiles in that bucket, we are writing image tiles that inherit the default object ACL of the bucket. So if the bucket is private, the tiles are private and almost are very largely not useful, but it becomes an authentication layer where you can only view them if you have access to the objects in the bucket. So a couple of new parameters to go over. File format for map tiles. The default is auto, which means we're going to try to use JPEG everywhere we can to keep storage down as much as possible. Wherever we need transparency, we're going to use PNG formatted tile. If you want everything PNG, you can have that. You just choose file format PNG. Path is the prefix of that, where you want the map tile stored in your cloud storage bucket. It's like a folder in cloud. Yes. So min zoom, the default is 0. That's probably appropriate for most things. But max zoom and scale are important. You specify either scale or max zoom. I would always specify that when I'm doing an export map, because a lot of times you don't need to export more than the image, what's appropriate for the actual image you're exporting. So if it's Landsat, it's 30-meter imagery, you probably don't need to go beyond zoom level 30 or zoom level 12, maybe 13 if you can. Zoom level 30 would be insane. Yes, so we have a handy table in our user docs, which gives you a sense of what the pixel size is at each zoom level. Because when you export a map tile, it's going to be in Web Mercator. So there is, again, that implicit reprojection of the output of export map is a Web Mercator. Map tile is compatible with Google Maps API, as well as other web mapping APIs. It's a standard web map tile, ZXY. So I exported this high resolution ortho imagery, a few zoom levels of it. And this is zoom level 15. It's only 4 images. So it's a really small area, but here's how I went to export it. My images this image is already an 8-bit RGB image. Well, it's RGB plus near infrared. So I just took the RGB bands, grabbed the area of interest, or defined the region as the extents of that asset, and exported from zoom level 0 through 16 to this bucket. So again, with this sample script, you want to change the bucket if you're trying to export it, because it's not going to let you export to mine. So we can view the exported map if you have a laptop. This is script. I don't remember. Script 6. No, this is actually not an Earth Engine script, right? It's a public URL. So when you export map tiles, it's also going to create an HTML file in the root directory of where you're exporting the tiles to, which gives you this. It's an immediate way to preview the map tiles. It's just a very simple Google Maps API HTML page where you have the map in the background and your exported map tiles on top. It's a panable, zoomable web slippy map. So we can zoom out, see what it looks like at zoom 0. It's almost invisible at that point, but yes, it's a really, really small at that. So yes, if you want to check, like, is this accessible to users who don't have Earth Engine, open it up on an incognito window. You'll see that these map tiles are publicly accessible.
Where do you get the bucket? Using the bucket stuff.
Yes.
Bucket, so you have to get that.
Yes. So if you want to export map tiles, similar to if you want to export anything to cloud storage, you need to have a cloud storage project with billing enabled, and you create the bucket in there, or you have write access to a bucket that already exists.
Right.
So if
Your organization has one.
right. But if you're going that route again, you want to be aware of that write public tiles flag and make sure the bucket has a public default ACL if you want public tiles. Okay. Yes.
Can we get an estimate on how many times we do it once we send an extent?
Right now, you can't. Unfortunately, right now, the way you would want to do that, the way you could do that is export a single zoom level that's reasonable for the region you're doing and count the tiles. and then you could just sort of calculate the number of tiles, and you'll probably overshoot, but better to overestimate than under. For comparison, for like a Landsat scale, global export of map tiles, the Hansen Data Explorer, we ran some estimates for what the global forest change exported map is, and it was like $60 a year, I think, to store the tiles and to serve like all the GET requests on cloud storage. It's an estimate. If you're using higher resolution, or you're exporting higher zoom levels, it's going to create a lot more tiles. So the storage is going to be more, but that's a reasonable feature request.
Did you use 12 or 12 or 13 for the Landsat?
I do not know off the top of my head. I think it's 30 meter. The data set is 30 meter.
Yeah.
And 12 is 38.
Yeah, those.
Yeah. Don't know. I can't answer that. Can check that though. Okay, last thing, Geo for Good Cloud Credits Program. We have there's a lot of potential of Earth Engine playing with cloud services, and we have a program to support our users who want to use cloud as part of their research or their projects. So this is in my slides. It's just an application form you can fill out. It's also on the Summit website. We encourage you to apply for credits. And what's cool about the credits, it's not just for storage, it's actually, they apply for all of the cloud services. So if you want to extend your analysis or have a greater impact because you want to use the prediction API, for example, we have a program to support you in doing that. Okay, so with that, thank you, and questions.
Is there a way to export collection?
Not right now. There's not. If you wanted to export, so you want to end up with an image collection asset of assets. Okay, yeah. Not right now.
You can kind of staple something together using the Python API because it has all the right parts, but you know, it's a lot of stuff.
Yes.
Is there a way to export vector data
Into a fusion table, there is not. You could export KML though, and it's going to be a format that you don't have to do anything before uploading the fusion table. I'll write that down as well.
The steps that people usually go through here are exporting as a KML file and uploading to Fusion Table, which is the two-step dance you used to have to do with imagery. Still have to do it with tables.
I'm not familiar with it. I know what I want to do with my system.
Our documentation talks a little bit about getting access to that data.
Yes.
In the importing part from the command line, if you have a time series, let's say 100 imagery, and you have some gaps on the dates, is there any way to pass a text file with all the dates inside there, instead of me typing the date for each one of the files?
So you would upload each into a separate asset?
Yeah, or having, getting the date, the time start, or the system time start to each image in a time series.
Right.
Because what we showed was a spatial file.
Right. It was 4 images that were really from one image. So if you have 4 images that are from 4 different dates, you would want to have 4 different assets created. So it would be 4 different Earth Engine upload commands.
Yeah.
Which if you can do some shell scripting to populate that. Yeah. Yes. I'm a fan of GNU parallel.
Yeah.
Oh, love that. Nuke them if you want, keep them if you want. Yes.
When you're doing an export from Python, the batch job is starting, is there a way to monitor it, get a notification